That's great. Thanks for coming back. Now, for episode 2, let's take an example based off of everything we learned and apply it to a example question. So, for episode 2, let's say it's example 1. Now, we're going to take a beam with a roller and a pin and apply everything that we learned. So here we have a roller with a pin, and we're going to apply a 10 kip load at the center, and it'll be a beam that is 10 feet long. Sweet. So we're going to go ahead over here and draw a 3-body diagram. Now this is where you draw the beam, draw the loads, draw the length, and you draw the image of the reaction. So I'll do this in green. So here we're going to go ahead with the beam. We're going to draw the load, which is 10 kips. We're going to draw our reaction. So we know that over here, we only have a one-dimensional reaction. So I'll call this point A, I'll call this B. So this will be reaction A. And over here, we also have a two-dimensional. So this will be RB. And then I'll call this horizontal one RB, RBX. And I'll just remind everyone that it is 10 feet long. So now what we need to do is find the reaction forces. So we're going to take Newton's law. Sum of the forces in the x direction is equal to 0. Will indicate that any force to the right is positive. So we can already see that RBX is equal to 0. So negative RBX equals to 0. Therefore, RBX is equal to 0. So this one we don't really have to worry about. Now what we have to do is worry about the vertical. So now we'll pay attention. Say the sum of the forces in the y direction is equal to 0. Indicate that up is positive. And then we'll say, well, we have one positive, two positive. So we'll say RA plus RB minus 10 kips is going to give me a total of 0. So now I have to figure out what RA is and RB is. I know that due to symmetry, since this 10 kip load is located right at the center, so it's located at 5 feet from each half. 5 feet, 5 feet. I know that due to symmetry, this is going to have to equal to that. Okay? So what I can do is say that RA plus RB is equal to 10 kips. And I know that RA is equal to RB based off of the assumption that this is going to carry half of the load of this. So this is going to carry half, that's going to carry half. So that means that it's going to be carrying half of this, which is essentially 1/2 times 10 kips, which is equal to 5 kips. So that's a shortcut way of doing this problem. So we can kind of box it. And that's it.